Most people are trying to fix their minds by thinking harder and their bodies by pushing more, never realizing that both are quietly governed by signals they repeat every single day. Your brain is constantly listening, not to your goals or intentions, but to your habits, your breathing, your sleep, your movement, and your attention. Long before motivation shows up, biology has already decided how clearly you will think, how strong you will feel, and how resilient you will become. When you understand that peak mental clarity and physical power are not earned through force but wired through daily signals, you stop chasing change and start becoming it. The first habit begins quietly, often unnoticed, yet it shapes the entire neurological landscape of the day. When you expose your eyes to natural light soon after waking, you are not just seeing the morning, you are signaling time itself to your brain. Specialized cells in the retina communicate directly with the hypothalamus, the region that governs circadian rhythm, hormone release, and core body temperature. This signal tells the brain that night has ended and that the systems responsible for alertness, coordination, and metabolic readiness can come online. Without this signal, the brain operates in partial confusion, releasing hormones at the wrong times, dulling attention, and making the body feel heavy before the day has even begun. As light enters the nervous system, cortisol rises in a healthy, purposeful way. This is not the cortisol of anxiety or pressure, but the cortisol of readiness. It sharpens perception, increases blood sugar availability for neurons, and improves reaction speed. At the same time, melatonin production slows, preventing the lingering grogginess that clouds thinking and weakens physical output. Over repeated days, this light-driven rhythm stabilizes sleep quality at night, which further amplifies mental clarity and physical recovery. The brain learns when to be alert and when to restore, reducing internal friction that many people mistakenly attribute to lack of motivation. Gentle movement layered onto this light exposure deepens the effect. A short walk, slow stretching, or relaxed mobility work sends sensory feedback from muscles and joints to the brain's motor and balance centers. This feedback recalibrates posture, improves proprioception, and increases blood flow to regions involved in coordination and focus. The brain interprets this movement as evidence of safety and capability. In evolutionary terms, a moving body in daylight signals survival conditions, not threat. As a result, the nervous system shifts away from defensive patterns and into a state optimized for learning, decision-making, and controlled strength. This combination of light and movement also primes the cardiovascular system. Blood vessels respond by becoming more elastic, heart rate increases smoothly rather than abruptly, and oxygen delivery to tissues improves. For the brain, this means a steadier supply of fuel and fewer energy crashes later in the day. For the body, it means muscles warm efficiently, reducing injury risk and improving power output even hours later. What appears simple on the surface is, in reality, a full system calibration over time. This habit reshapes neural expectations. The brain begins to anticipate clarity rather than chaos in the morning. Stress circuits quiet more quickly. Dopamine pathways associated with motivation become more responsive, not because of stimulation, but because timing is aligned. You may notice that focus arrives earlier, that physical tasks feel less effortful, and that emotional reactions soften. These are not psychological tricks but biological consequences of respecting how the brain measures the passage of a day. Importantly, this habit does not demand intensity. The brain does not reward force here, it rewards consistency. Even on low-energy mornings, standing near a window or stepping outside for a few minutes reinforces the signal. The nervous system values reliability over perfection. Each exposure strengthens the association between morning and activation, teaching the brain to organize itself efficiently. Over weeks and months, this rhythm becomes internalized, allowing clarity and physical readiness to emerge without conscious effort, driven by biology that has learned, once again, how to recognize the beginning of a day. The second habit centers on something so constant that it often escapes attention, yet it holds direct authority over the nervous system. Breathing is the only autonomic function that can be consciously guided, which makes it a bridge between intention and biology. When breathing becomes slow, deep, and nasal, it alters the chemistry of the blood and the signaling patterns of the brain almost immediately. Carbon dioxide levels rise slightly, which improves oxygen release from red blood cells to tissues, including the brain. This alone enhances mental clarity, but the deeper influence unfolds through neural communication rather than oxygen alone. Slow, controlled breathing activates the parasympathetic branch of the nervous system, particularly through stimulation of the vagus nerve. This nerve carries information from the lungs, heart, and gut directly to the brainstem and higher brain regions. When the exhale is extended, vagal tone increases, heart rate variability improves, and the brain receives a signal that the body is safe. In response, stress hormones decrease, muscle tension softens, and the brain's threat detection circuits reduce their constant scanning. This creates mental space, not as emptiness, but as order, allowing thoughts to form with less internal resistance. As this state becomes familiar, the brain begins to recalibrate its baseline. Areas responsible for emotional regulation, such as the prefrontal cortex, gain greater influence over reactive limbic regions. This means that challenges are processed with clarity rather than urgency. Decisions slow just enough to become precise. Physically, muscles receive steadier neural input, reducing unnecessary co-contraction and wasted effort. Strength feels smoother, more coordinated, less driven by brute force. The body moves with efficiency because the brain is no longer issuing conflicting commands. Breathing also affects how the brain processes sensory information. Rapid, shallow breaths narrow attention and amplify threat perception, a useful response in danger but exhausting when sustained. Slow breathing widens perceptual bandwidth. Sounds become less irritating, visual focus sharpens, and bodily sensations become more interpretable rather than overwhelming. This improves movement quality, balance, and reaction time. Athletes and patients alike experience this as feeling more present, though the experience is grounded in measurable neural shifts rather than abstraction. Over time, deliberate breathing reshapes the brain's predictive models. The nervous system learns that calm can be generated internally without changing external conditions. This rewiring reduces dependency on stimulation, distraction, or avoidance. Dopamine systems stabilize, making effort feel less draining and rest more restorative. Physical recovery improves as inflammatory signaling decreases and digestive efficiency increases, both influenced by parasympathetic dominance. The body becomes more responsive to training and less reactive to stress. What makes this habit powerful is its portability. It does not require silence, special posture, or extended sessions. A few minutes of slow breathing woven into daily life is enough to reinforce the signal. The brain responds not to duration, but to frequency. Each intentional breath becomes a vote for regulation over chaos. Over weeks, the nervous system adopts this pattern as default, allowing clarity to surface even under pressure. This is not a technique to escape discomfort, but a way to meet it with stability. By guiding the breath, you guide the conversation between brain and body. Strength becomes quieter, focus becomes deeper, and calm stops being something you hope for and becomes something your biology knows how to produce on demand. The third habit is built around effort, not exhaustion, and challenge, not punishment. When the body is asked to push against resistance, the brain interprets this as a meaningful signal that adaptation is required. Muscles contracting under load generate electrical and chemical messages that travel through sensory nerves to the spinal cord and upward into the brain. This information does more than coordinate movement. It stimulates the release of growth-related molecules that support neural health, learning, and emotional stability. What feels like a physical act is also a neurological conversation about capability and resilience. As resistance is applied, motor neurons fire in coordinated patterns, improving the brain's ability to recruit muscle fibers efficiently. This efficiency reduces wasted energy and increases strength without unnecessary strain. At the same time, the brain releases factors that promote synaptic plasticity, reinforcing connections involved in memory, attention, and mood regulation. These changes are not abstract benefits, they manifest as clearer thinking, improved confidence, and a more stable emotional baseline. The brain learns that effort leads to reward rather than threat, reshaping how it responds to future challenges. Resistance training also has a profound effect on metabolic signaling. When muscles contract, they increase glucose uptake independent of insulin, stabilizing blood sugar levels that the brain relies on for consistent energy. Fluctuating glucose impairs concentration and increases irritability, while stable supply supports sustained focus. Over time, improved insulin sensitivity reduces inflammatory processes that interfere with neural signaling. The brain benefits from a cleaner internal environment, and the body experiences more predictable energy rather than cycles of fatigue and stimulation. The hormonal response to brief, consistent resistance work further deepens the adaptation. Growth hormone and testosterone rise within healthy ranges, supporting tissue repair, bone density, and neuromuscular coordination. Cortisol increases temporarily but returns to baseline efficiently, teaching the nervous system how to handle stress without remaining locked in it. This pattern trains resilience at a cellular level. The brain internalizes the lesson that pressure can be met and resolved, not avoided or prolonged. Psychologically, the experience of controlled effort rewires perception. Each repetition is a small confrontation with discomfort that ends in success. This alters threat prediction in the brain, reducing anticipatory anxiety and increasing tolerance for challenge. The prefrontal cortex strengthens its regulatory influence, allowing intention to guide action rather than impulse. Movement becomes more deliberate, posture improves, and breathing synchronizes naturally with effort. Physical power feels integrated rather than forced. Consistency matters more than intensity because the brain tracks patterns over time. Short, regular sessions create repeated signals of adaptation without overwhelming recovery systems. This predictability allows the nervous system to invest resources in growth rather than defense. Over weeks, movements become smoother, strength increases with less conscious effort, and fatigue recedes. These changes reflect a nervous system that has learned to trust the body's capacity to respond. Importantly, resistance does not only strengthen muscles, it clarifies identity at a biological level. The brain encodes repeated successful efforts as evidence of competence. This alters self-perception in subtle but lasting ways, influencing posture, speech, and decision-making beyond the training environment. Physical power becomes a reference point for mental steadiness. In this way, lifting, pushing, or pulling against resistance becomes a form of neural education, teaching the brain that growth lives on the other side of effort, and that strength, once practiced, becomes a stable internal resource rather than a temporary state. The fourth habit is the practice of sustained attention without constant stimulation, a skill that has become rare in an environment designed to fracture focus. The brain evolved to move between periods of alert engagement and quiet integration, yet modern input keeps attention in a state of perpetual fragmentation. When attention is repeatedly pulled in different directions, neural resources are scattered, and the brain struggles to distinguish what is important from what is merely novel. This does not only affect thinking, it alters posture, breathing, and muscle tone, leaving the body subtly tense and inefficient. When you choose even a short period of single-task focus, something fundamental shifts. Neural activity in the prefrontal cortex becomes more organized, allowing it to regulate impulsive circuits that seek constant reward. Dopamine signaling, which is often overstimulated by rapid input, begins to normalize. This recalibration makes effort feel meaningful again rather than draining. The brain no longer chases stimulation, it settles into purpose. As attention stabilizes, the nervous system reduces unnecessary alertness, and muscle tension begins to unwind without conscious instruction. Focused attention also strengthens the brain's ability to filter sensory information. Instead of reacting to every sound, notification, or thought, the brain learns to prioritize. This filtering conserves energy and sharpens perception. Vision becomes steadier, hearing less intrusive, and bodily sensations more interpretable. These changes directly influence physical coordination. Movements become cleaner, balance improves, and reaction time becomes more precise. The body reflects the mind's order, moving with intention rather than haste. On a deeper level, sustained attention alters how the brain experiences time. When attention is fragmented, time feels rushed, creating a sense of constant urgency that elevates stress hormones and impairs recovery. Focused presence slows subjective time, allowing neural processes to complete their cycles. This supports memory consolidation and emotional regulation. The brain is given space to integrate experience rather than simply react to it. Physically, this integration reduces chronic muscle guarding and supports efficient breathing patterns, which further reinforce calm. This habit does not require meditation in the traditional sense, though it can include it. It can appear as mindful walking, slow repetitive movement, or fully engaging in a single task without interruption. What matters is the absence of competing stimuli. In these moments, the brain strengthens connections that support patience and restraint. The prefrontal cortex gains durability, allowing it to maintain control under pressure. This control is not rigid but flexible, enabling adaptation without panic. Over time, focused attention reshapes the brain's reward system. Dopamine becomes associated with depth rather than novelty. Satisfaction arises from completion rather than constant anticipation. This shift reduces compulsive behaviors and mental fatigue. Energy that was once spent on distraction becomes available for physical performance and creative thought. The body feels lighter not because it is weaker, but because it is no longer carrying unnecessary neural tension. The physical effects are subtle yet profound. Heart rate becomes more stable, breathing deepens naturally, and posture aligns without conscious correction. These changes reduce wear on joints and muscles, improving endurance and strength expression. The nervous system learns that stillness is not stagnation but preparation. In this state, both mind and body operate from coherence rather than conflict, allowing clarity and power to emerge as natural byproducts of attention that has learned how to remain whole in a world that constantly asks it to fragment. The fifth habit is the protection of deep, regular sleep as a biological necessity rather than a negotiable luxury. Sleep is not a passive shutdown of the brain but an active, highly organized state in which restoration and recalibration occur at every level of the nervous system. As the body enters sleep, brain activity shifts into patterns that allow neural circuits to communicate internally without interference from the external world. This internal dialogue is essential for mental clarity and physical power, because it determines which connections are strengthened and which are allowed to fade. During deep stages of sleep, the brain engages its cleaning systems, flushing metabolic byproducts that accumulate during waking hours. These substances, when left uncleared, interfere with signal transmission and slow cognitive processing. By removing this neural debris, sleep restores the brain's ability to think sharply and respond accurately. At the same time, synaptic connections formed through learning and movement are refined. Useful pathways are reinforced, while excess noise is reduced. The result is not just better memory, but a more efficient brain that expends less energy to achieve the same or greater output. Sleep also governs hormonal balance in ways that directly affect physical strength and mental stability. Growth hormone is released in pulses, supporting muscle repair, tissue regeneration, and bone strength. Cortisol levels fall, giving stress systems time to recover. Hormones that regulate appetite and energy use are recalibrated, preventing the erratic hunger and fatigue that undermine both focus and performance. When sleep is consistent, these systems regain rhythm, allowing the body to generate power without drawing excessively on stress reserves. Emotionally, sleep acts as a regulator of perception. During certain sleep phases, emotional experiences are processed in a way that separates intensity from memory. This allows difficult events to be remembered without triggering the same physiological response. The brain learns that challenges can be stored without being relived. This emotional regulation improves decision-making and reduces impulsivity. Physically, it translates into smoother movement and steadier breathing, as the nervous system is no longer burdened by unresolved stress signals. The timing of sleep is as important as its duration. Regular sleep and wake times anchor circadian rhythms that influence temperature regulation, immune function, and cognitive alertness. When these rhythms are stable, the brain anticipates rest and activity efficiently. Energy becomes predictable rather than erratic. Strength improves not because effort increases, but because recovery is complete. The body enters training or daily work already prepared, rather than compensating for fatigue. Protecting sleep also changes how the brain responds to pressure. Well-rested neural circuits are more flexible, allowing rapid adaptation without overreaction. Reaction time improves, attention stabilizes, and complex tasks feel manageable rather than overwhelming. The body benefits from reduced injury risk and faster recovery as tissues repair fully and inflammation resolves. Over time, this resilience becomes part of the nervous system's baseline rather than a temporary state. Sleep does not demand perfection, but it does require respect. Small choices made in the evening, such as reducing artificial light and mental stimulation, signal the brain to transition into restoration mode. Each night of consistent sleep reinforces the brain's trust in the future, teaching it that resources will be replenished. In this trust, both mental clarity and physical power find room to grow, sustained not by constant effort, but by a biological rhythm that supports strength, focus, and balance as natural expressions of a nervous system allowed to fully recover.